Okay, 3.4 notes, experimental design. So there are three types of experimental designs we will discuss: completely randomized, randomized blocked, and match pairs design. These are the most common three that are going to pop up on the AP exam. So let's first talk about principles of experimental design. So first is comparison. We want to make sure that we are using a design that compares two or more treatments. We need to make sure that the groups we are comparing don't differ greatly before our experiment begins, or we could end up with a bias. To compare different treatment groups, we have to set up different factors and levels. A factor is the explanatory variable in the experiment. It's deliberately manipulated. And then the level are the various groups that the factor takes. The combination of levels from all the factors that an experimental unit receives is called a treatment. Okay, so a treatment consists of factors and levels. So in the example, it says a researcher wants to test the effects of a combination of diet and exercise on weight loss. The diet groups will be less than 2,000 calories a day, between 2,000 and 3,000, and over 3,000 calories in a day. The exercise groups will have 3 or less periods of exercise a week, 4 or more periods of exercise a week. All combinations of treatments will be examined. How many treatments, factors, and levels are in this study? So first are factors. Okay, so what are we comparing? Well, we're comparing diet and exercise. Okay, now we talk about levels. Okay, well, for each of them, we had 2. So for diet, it was less than 2,000 calories, between 2,000 and 3,000, and then greater than 3,000. Okay. And then for exercise, it was less than or equal to 3 times per week and greater than or equal to 4 times per week. Okay. Then we have the treatments. Okay. So for the treatments, what we're doing is that we are taking one of the diet levels and pairing it with both the exercise times. And we're going to do that for each of them, which means we have the first one being less than 2,000 calories and less than or equal to 3 times per week. The next one would be less than 2,000 calories and greater than or equal to 4 times per week. The next one would be between and less than or equal to 3 times per week. The next one would be between and greater than or equal to 4 times per week. The fifth one would be greater than 3,000 and less than or equal to 3 times per week. And then the last one would be greater than 3,000 and greater than or equal to 4 times per week. Okay. Which means there's 6 treatments, 2 levels, and 2 factors. Okay. The next one is randomization. Randomization must be incorporated either in the selection process of the experimental units or in the distribution of experimental units. This one is the most common. We only compare when the groups are as similar as possible before the treatment is applied. Randomization produces groups of experimental units we expect to be similar in all respects before treatments are applied. Therefore, measured differences must be due either to the treatment or by chance of random assignment. Then we have control. A group that is treated the same as the treatment groups but does not receive a treatment. The experimental units in this group should not know that they are not receiving a treatment. The control group is our baseline, and our experimental group has only one thing changed, and that's the explanatory variable. This reduces variability in the response variable. Next, we have replication. Use enough experimental units in each group so that any difference in the effects of treatments can be distinguished from chance differences between groups. In statistics, replication means we used enough subjects. Whereas in other fields, replication means repeating. So replication means we used enough subjects. Even with control, natural variability occurs among experimental units. We would like to see units within a treatment group responding similar to one another but different from units in other treatment groups. If we assign many individuals to each treatment group, the effects of chance and individual differences will average out. So now designing experimental studies. This is a completely randomized design. It says in a completely randomized design, experimental units are assigned to treatments by chance. When describing a completely randomized design, it is important to identify when the random assignment occurs using labels such as RA on the diagram, and then how it was randomly assigned. Okay. And so this would be us saying, okay, well, we're going to identify the sample. We're going to randomly assign subjects. We're going to identify the treatment. And then we're going to compare the results. Okay. When randomly assigning subjects, split them as evenly as possible. Some groups may be uneven, but they should not be significantly different. Okay, the following example. Medical professionals in obstetrics want to study how different brands of prenatal vitamins may impact iron levels of expecting mothers throughout their pregnancy. The study follows a sample of 50 expecting women from 4 weeks of pregnancy through their delivery. They have 5 different brands: Rainbow Light, Nature Made, Mega Food, Ritual, and Nordic Naturals. For this experiment, a control group is not allowed. Why? Describe and design a completely randomized experiment. Let's first answer this question. Why is a control group not allowed? Well, it would be not allowed because it would be unethical to not give a pregnant woman vitamins. That's why it would be not allowed, because it's unethical. So now let's talk about our design. So first we have our 50 pregnant women. Okay, I am going to randomly assign them to each of the 5 groups. So I have Rainbow Light, Nature Made, Mega Food, Ritual, and Nordic Naturals. Okay, Then after everything is randomly assigned, I'm going to compare iron levels. Okay, so since I start with 50 pregnant women and I want to randomly assign it to each of these, well, since there's 5 groups and 50 women, I could assign 10 to each group. And then find the results of each of them by comparing their iron levels after birth. How do you randomly assign 50 pregnant women to a different treatment? So not only do you need to know how to draw this, you also have to be able to describe this in words. So we would say we would assign each pregnant woman a number 1 through 50. We would randomly generate 10 numbers and put them in the first treatment group, which is the rainbow light. Then we would randomly generate 10 new numbers and put them in the second treatment, which was nature made. Then we would repeat until only 10 women remain for the final group, which is Nordic Naturals. Okay, randomized block design. Experimental units are divided into groups or blocks prior to the experiment. This reduces the effect of identifiable attributes of the subjects that cannot be controlled. It tests the hypotheses about difference between groups and examines the differences caused by the treatments more clearly. Blocking is used to control the factors you can see. Randomization helps balance the ones you cannot see. Very important. Okay, so this would be us identifying a sample. Okay, block the subjects, so put them into blocks. Randomly assign the subjects. Identify a treatment. Compare the results, and then combine the results from each block. So for example, it says, does cold water or hot water clean laundry better? Does the color of the laundry matter when cleaning hot or cold water? You have 4 piles of dirty laundry to test this question. Describe and design a completely randomized block design. Okay, so we have 4 piles of dirty laundry. Well, let's separate those into 2 piles of light clothes and then 2 piles of dark. Okay, we're going to randomly assign each of these to either cold or hot water. Okay. We're going to compare cleanliness and then combined results. Okay. So it says, how do you randomly assign your experimental units to the treatment? So I could say In the light close block, we assign one pile to heads and one pile to tails. Flip a coin. Whatever it lands on, goes to cold water, and the other to hot. Repeat for dark close. And then lastly, we have a matched pairs design. So it says, in this design, each experimental unit receives both the treatment and the control. The order that the treatment and control is assigned should be random. And if subjects are used, they should not know which treatment is the treatment or the control. Another way to do the design is to pair up units so that they are as similar as possible, and then every pair receives both treatments by random, assigning one treatment to one member of the pair and then assigning the remaining treatment to the other member of the pair. Okay. It says, does listening to classical music improve concentration during a task compared to not listening to any music? A group of 30 students volunteer with a complete series of logic puzzles, once by listening to no music and once by listening to classical music. The logic puzzles will be slightly different for each administration of the treatments. Describe and design a matched pair experiment. Okay, so we have 30 subjects. Okay. We're going to label them the first subject all the way to the 30th subject. Okay. Each of these are going to be randomly assigned to either classical music or no music. Okay, and then whatever they get first, they always are going to get the other one next. Then we're going to compare the results. We're going to do this for every single subject until we get to the 30th and do it for that one as well. And then compare. So it says, how do you randomly assign your experimental units to the treatments? So it says, I will randomly assign each treatment within each individual subject. Okay, so we will assign each treatment within each subject. For subject number 1, we will flip a coin. If it lands on heads, it's classical music first, then no music. If it lands on tails, it's no music, then classical music. This is repeated for the other 29 subjects.